Super duper live. Unplugged. Extra fun. So here's 14 on that lovely worksheet. Guess what? 14 through 17 are not on the quiz, so you can relax. This is just cool stuff. That doesn't show up directly in your notes, so this is going to be it. This is like the place. We're going to do something cool. And it's kind of U substitution, but at a special level. Here's what we're going to do. We are given an integral here. Oh, I need a bigger highlighter. Grow up. Okay, let's try this again. That's what I'm talking about. There is this integral that we know the value of. The one on the right resembles it as a distant cousin, let's say. So what that means, if I have to find an integral that looks like one I know the value of, that means I probably need to change the one to look like the one on the left. And if you can notice, really the only difference is this kind of coefficient of 3 and what I'm taking the cosine of. And that coefficient of 3 right there, well, that's pretty easy to take care of if you can imagine. That's the same as just pulling a 3 out front and calling it 1 plus cosine of x over 4. So that takes care of that, and that then is just a 1/3 that we can pull out front. So this becomes 1/3, and these become 1s. So that's good. Now it's looking very much like its cousin. Okay, over here. The only thing now is, darn it, I only know if there's an x here how to do this. Well, this one's got x over 4. Does anyone have any cool ideas? I mean, since this is the U sub section, I mean, you're welcome to try that. It's not the only way to do it, but you can kind of mentally tackle it. Let's just take the direction and say U sub. Okay. U equals x over 4. So that's what we'll do. And then if I do du, then it's 1/4 dx. What? Who knew? And then, if I want to do U substitution, I just need to get that. I don't see a 1/4 up here, so I'm going to get the 1/4 out front. So according to all this, I should get not only the 1/3 out front, but a 1/4. And 1 over 1 plus the cosine of u, du. Okay. Or if you like, you can put the du up on top and make that 1 over 3 times 4. We could make it 1/12. Okay, sounds good. Okay, that right there looks awfully similar to that dude, except for the 1/12. And then it's got a u. So we can sub it out of there. So knowing that the chunk that we see, let's change my highlighter colors. Let's go a little yellow. This right here is equivalent to the tangent of, in this case, u over 2 plus c. The only thing I need to add to it is a 12th, and then put u back. And then we got this thing. So that's what I'm going to do. So this will be 1/12. Kind of working from right to left. That's odd, isn't it? Tangent of my u, which is x over 4, over 2 plus c. And that's it. It ends up being 1/12 the tangent of x over 8 plus c. And I'll probably write that over here. 1/12 the tangent of x over 8 plus c is a nice final statement. Bold. So that's the cool thing about U substitution, is you're just swapping it out so that it looks like something you do know. Like arctangent. Remember yesterday, arctangent's like a squared plus x squared in the denominator. We can do U substitution and make that happen. We can make it look like an arcsecant, arcsine, that kind of stuff.
You think that it might be 4/3 instead of...
Why? Because there's a 4 in front of the du that I forgot to put there?
Well, no, because you multiply the bottom instead of the top.
You mean like this?
Because like it cancel out if there's like 4 times the...
Frank, we can't change that this is recorded. This is like a permanent. 4 du equals dx, is that what you're talking about? Like, then it makes it like 4 and not 1/4. Okay. I can't erase that easily, but that sounds pretty good to me. I'll go back and fix it. Who's we, by the way? Should we blame? We need to blame somebody else for this too. Okay. Eraser. Okay. Yeah, thanks. I kind of didn't finish. 4 du replaces my dx, hence 4/3. Good call. Anything else goofy on there? But that's the fun of it. Okay, now that is something different with u substitution maybe, because we were working towards arcsine, arcsecant. We're making it look a certain way so that we can quickly integrate. Same thing happens in the next one, but in 14b, we are missing a tool that I'm going to get to in your notes in order to do this one. Watch what happens if I try and approach this one the same way. Usually we go for like an exponent and say u would be 5x. But in this case, if I do the derivative of that and just go ahead and take care of that 1/5, and I get 1/5 du, since I know I'm going to forget it, I better just do it. 1/5 du equals dx. I can't replace this. X currently has no replacement. And so there's a way to tackle this, and it's not that complicated actually. And it involves, well, I just need to replace it so that my expression is now in terms of u, because this is what I've got going so far. I've got the integral, and I got x on top. I can replace dx with 1/5 du. I can replace the 5x with u. So I got e to the u plus 1 du. The only thing is I got to get rid of this pesky little x sitting up there. So I'm going to put it in a different color and say, how am I going to deal with you, pink x? You know how we're going to deal with it? It's as straightforward as you might want to think. Kaylin's got this down. She wrote it down like 10 years ago. This. Solve for x in my u substitution. So u equals 5x. What we haven't really experimented with is u substitution is just replacing, if you establish an equation that u is equivalent to some portion of your function you're integrating, you're more than welcome to solve for x or any other variable in it and use it in your substitution process. It accomplishes a very, very important goal. It replaces that x with something that has a u in it, and we're off and running. Now, why might that be advantageous? This little dude, this is nice. So I can pull out the 1/5. I'll let you think where that comes in. Is this one doable? Is it more doable than the last one?
Collectively, C, shouldn't you have 1/5 du in that equation?
Ah,
And
so
1/5 u?
this one down here, so 1/5 du. So there's a 1/5 that out front. Is that what you're talking about?
Yeah.
It's right here.
Yeah, right there. Yeah, sorry.
Okay.
So missed that.
No, and I think I just wrote 1 and forgot the other one. So that's fair. So this is 1/25 if we put them together.
Yeah.
Is this better? No, you can keep at finding things, but is this any better than what we started with? Is that any better? Any better at all? And that's what we'll find out. So leave that there. 14b should look a little bit better after we go do a couple problems in the notes that are similar to that, where we solve for x. And I think you'll be happy. I think you'll have it. Okay? So onward and upward. And if that doesn't work, then maybe there's another way we can solve that makes it even better. And I'm excited about that too. And I'm open to thoughts, but I don't want to resolve your homework. Same thing, let's turn the page real fast. 15 is a similar version of what we just did, and it goes quite nicely. I bet if you were to guess, here's the equation that we were given, right there. Some kind of equivalence. I would really like this expression down here to look like that, to be similar in some way. And if you'll notice, the only thing that's keeping them slightly separate is that this has a 5x and this one doesn't, and the bounds are different. So those are the differences that go on in there. So to reconcile that, this one's very straightforward, and I thought I'd give you a clean one here. U equals 5x would turn that into an expression that looks a lot more like the one above. And this one does work out nicely, so don't panic or anything. This is going to be clean. But there's some substitution issues that are kind of cool. Okay. This ends up being 1/5 du equals dx. Double check all the 1/5 and fun stuff that I may or may not write. So when I substitute this one, I'm going to get an integral natural log a plus b cosine of u. And then if you notice that 1/5 du is going to, it will replace the dx, so this 1/5 will come out front, and there's a du. Cool, we got it. Ready to roll. Now that looks pretty good. I don't know about you, but I think I see the same thing here. I should probably pick something other than purple. Hang on. This right here is looking a lot like this up top. And that's a good thing. The deal is, though, I know the value of this integral above only from 0 to pi. Currently, I'm looking at 0 to 5, pi over 5 is my upper bound and lower bound. Well, if we follow suit with what we were doing yesterday, this is in terms of u right now. And so my bounds also need to be in terms of u. So we need to get u bounds. So my lower bound would be u equals, I just need to plug the x bound into my u equation. So I'm using u equals 5x to convert it. So 5 times the x bound of 0 is 0. So my 0 is going to be my lower bound. My upper bound I'll get from u equals 5 times pi over 5, which would be pi. And what do you know? That's pretty slick. Check it out. The upper bound in terms of u is pi and the lower bound is 0. That is a dead ringer for the equation that I got in the beginning, except for the 1/5. So what I know this to be equal to, since I've converted my bounds, once you turn these in terms of u, you've converted them to match, you never want to put u back. Never, ever, ever. Once you've converted your lower and upper bound, don't put u back. So this ends up being, it's 1/5, since up above it was 2 pi ln of 2 is what this is equivalent to, the expression above. The only thing I need to contribute is this 1/5, so it's 2/5 pi ln of 2. So it's a cool deal when you can make it look like something you know the value for. And making u equal 5x. Little u substitution, we had to change the bounds. And this is an academic type of problem, so that the bounds 0 and pi over 5 were setting you up so that after you converted them, they would be 0 and pi, and everything was peach keen. So that's the story on that one. Clean. 14b is just slightly different, but 15 is clean. 14a is very clean, very nice. Anything on that one you want to ask real quick? Because we're going to start the quiz in a few minutes. Okay, last. I think we can save 16 and 17 are related. They're transformations on a function, very fun. But I think we should do it after the quiz if we have some time. If not, we'll just put it off until tomorrow. It's not pressing.